In this short video, you will learn how to select points for APR models for a typical horizontal pump motor combination. Let's begin by sketching the motor, pump, and coupling arrangement. We'll continue by drawing our inputs and outputs. The motor has an input of power, conversion of electrical to mechanical power, and finally output of that mechanical power to the pump via the shaft or coupling. We'll continue by looking at the pump. The pump has an input of water and an output of water that has been pressurized by the impeller. Next, we'll look at these components separately and define the typical instrumentation for basic modeling. If we look at the motor alone, for example, draw a boundary represented by the outside rectangular box, we can quantify power in by using voltage V and current I. Note that torque is not often measured and is therefore not available to monitor, but we can usually monitor V, I, and temperature of the stator, which is usually a temperature of just one winding. The conversion of electrical power to torque, or mechanical power, also produces vibration and heat in the motor. Vibration will be considered as part of a rotor coupling pump dynamic system. Finally, it is useful to include influences such as pump load. Next, let's consider the pump alone. The pump's purpose is to pressurize the incoming fluid. Many times this is water. The typical measured parameters are inlet pressure and inlet temperature, then outlet temperature and outlet pressure. As the pump rotates to produce this pressure increase, vibration and heat are produced in the bearings. Other variables we will want to include in a pump model due to their influence effects are pump header pressure and pump header temperature, and also motor torque if available. Next, let's consider the bearing temperatures and lubricating oil system. The lube oil tank supplies oil at a high pressure to the bearings. The bearing temperatures often are measured, including metal temperatures and oil drain temperatures. This model should include each bearing temperature and the lube oil supply and return temperatures. The lube oil is also often cooled by an external water source, and if available, the temperature and pressure or flow of this cooling source can be modeled as well. Other influence variables include ambient air temperature, pump load, and motor power. Finally, consider the rotor coupling shaft arrangement as a dynamic system for vibration modeling. Since the shaft is coupled between components, the vibration at one end will affect the vibration at the other end. For this model, we include vibration probes at each bearing location, the shaft speed, pump load, and/or motor torque as influence variables. More complex models are often available to monitor, such as creating a detailed vibration model with additional features such as phase angle, particularly for proximity probe type of sensors, calculating motor efficiency, and monitoring motor current signature analysis. However, these basic models will get you started and are likely what you already have for instrumentation availability. Thank you for your attention, and if you have comments or questions, please write me at aaron.hussey@int-analytics.com.